In 4.2, we will learn how to identify the chemical reactions as one of these 5 types. We will go over each type with examples. The first type we will learn about are the synthesis reactions. These synthesis reactions are reactions that create or make or synthesize one compound. You can recognize these reactions as having 2 or more reactants and only one product on the right-hand side. The reactants can either be 2 elements, like in this first example, 2 compounds, like in this example, or you could have an element and a compound. There could also be 3 substances as the reactants, all combining together to make one product. In fact, combination reactions is another way to name these types of reactions. Decomposition reactions are essentially the complete opposite of synthesis reactions. We have only one reactant that is decomposing, breaking down, decaying, or breaking apart into 2 or more substances. In our first example, the reaction is not balanced, but we have KClO3 breaking down or decomposing into 2 different substances, KCl and O2.
I found this on the web.
Next, we have single and double replacement reactions. A single replacement reaction involves one single element and one compound on the reactant side. The single element will switch places with one of the elements in the compound. On the product side, there should be a different single element with a new compound. In our first example, H2 is our single element on the product side. Even though it is a diatomic element and needs the subscript 2, it is still considered just one single element. In our second example, we have a coefficient of a 2 on our single element iron on the reactant side, but that is just to balance out the reaction. We still have one single element iron switching places with one of the elements in the compound zinc chloride, or ZnCl2. Double replacement reactions involve 2 ionic compounds on the reactant side. One element from one compound creates or forms a new bond with one element from the other compound. You can see that we have silver and chlorine creating silver chloride on the product side. And then we have potassium and nitrate, NO3, creating potassium nitrate as our second compound. This is why it is extremely important that you are familiar with the polyatomic ions so that you recognize NO3 as one unit or one piece of the substance, and you don't break apart the nitrogen and the oxygen. In our second example, we have 2 polyatomic ions, ammonium and sulfate, SO4, creating one compound, and you can see that the ammonium and the nitrate are creating one compound on the product side, while we have barium and sulfate creating the other compound on the product side. Our last type of chemical reaction is very easy to recognize. Combustion reactions always have a hydrocarbon molecule reacting with O2. A hydrocarbon is a molecule with carbon and hydrogen, and sometimes it can have oxygen in it as well. This hydrocarbon combusts, burns, or reacts with the O2 in the atmosphere. No matter what the hydrocarbon looks like, something like CH4 or CH4O, or maybe even C2H6 or something like that, it doesn't matter what the hydrocarbon looks like, the products will always be carbon dioxide and water. Carbon dioxide and water. Candle wax is made up of a complicated hydrocarbon. When it burns, it uses up some of the O2 in the atmosphere around the candle, and it produces gaseous CO2 and gaseous water. Now you can go back through all of the chemical reactions in 4.1 and that you had needed to balance for that practice problem set, and now you can classify each type as one of these 5 types of reactions. So here's problem set 4.1. Even if you haven't balanced it yet, you can go ahead and classify this first one. You can see that you have 2 substances that are creating or forming one substance. This is a synthesis reaction. You can also call it a combination reaction. Problem 2 is a decomposition reaction because you have only one reactant decomposing into two separate compounds. The third reaction is a double replacement. You have Cl and Na creating NaCl, and then you have OH and H creating water. This is a double replacement reaction. You can see in example 4, this is a single replacement reaction. You have magnesium is going to switch places with the hydrogen so that magnesium and chlorine get to make a compound, and then hydrogen is by itself. And this is a single replacement reaction.